The topic being focused on is leptospirosis in Metro Manila. Leptospirosis is a disease which originates from the urine of small farm animals, the most common of them known to be rats. The disease is transmitted from water or soil that contain contaminated urine of the animal, and it can infect a person through the openings of their body, such as their eyes, mouth, nose, ears, and open wounds. If infected, the infectee will first undergo mild leptospirosis, which includes symptoms such as fever, muscle pain, diarrhea, rashes, etc. If the case is serious, severe leptospirosis will occur, which could cause liver and kidney failure, respiratory disease, meningitis, which could all be fatal. This disease is definitely a present problem in Metro Manila. This is due to the disease being more imminent in tropical climates. Moreover, Metro Manila is not only home to 12.8 million people but also to a large number of rats. With many homes and establishments present in Metro Manila, it is only right to say that they are big contributors to the trash in the area. Rats eat trash as a good food source, therefore, the more trash present, more rats will be attracted, which makes the risk of leptospirosis even greater. Leptospirosis is a zoonosis caused by bacteria of the genus Leptospira. It can be contracted by ingestion, inhalation, and direct contact with infected mediums, which are commonly soil and water. Infection of media is caused by the urine of carrier organisms, which are commonly comprised of rats, rodents, and other domestic animals. The infection itself, in humans and animals, is difficult to identify based on symptoms alone, as the effects cover an expansive array where some experience no symptoms, while others might develop kidney diseases, meningitis, and such, which could eventually lead to death if left untreated. As the treatment goes, patients are given penicillin or doxycycline for minor cases, while major cases require varying degrees of antibiotics. In addition, leptospira bacteria survive in humid environments where ambient temperatures range from 7 and 34 degrees Celsius. This makes areas with temperate climates less prone to harboring the disease, while areas with tropical climates such as the Philippines are ideal for its subsistence. Leptospira antibodies affect vulnerable communities, including but not limited to those who live in slum areas and agricultural workers. The risk of getting infected by this disease is related to different household environmental factors. This includes houses situated in areas with open sewers that are prone to flooding, vicinity to accumulated discarded matters, environment that favors the breeding of rodents, and livestock like chickens. Furthermore, leptospirosis inflicts two crucial problems to the human race: the direct oppression of sickness and medical expenses, and an indirect torment brought by livestock illness. The neglected tropical diseases like leptospirosis usually affect the less fortunate people who lack access to hospitals and clinics. NTP Interagency Center for the Evaluation of Toxicological Methods 2012. The lack of adequate diagnostic laboratory services and complications in identifying clinical signs from other endemic illnesses. Leptospirosis introduces different clinical indications that can eventually cause death. Nonetheless, this disease can be cured with the use of antibodies if detected early. The range of human diseases caused by this can vary from minor infections to severe ones with a high mortality rate. Kidney damage, meningitis, respiratory diseases, and/or liver failure are some of the acute disorders. With an average of 680 cases and 40 deaths each year, this zoonosis is prevalent in the Philippines, particularly in Metro Manila. As a matter of fact, leptospirosis affects more than 10 in every 100,000 people each year. An outbreak was declared in Metro Manila after the ravage of Typhoon Ondoy in the country. Communities were left submerged by the flood that is caused by a poor garbage collection system that clogs the drainage system. According to the National Epidemiology Center of Department of Health, there were around 2,299 assumed cases of leptospirosis in November of 2009. 15 hospitals in Metro Manila recorded a total of 178 deaths in a span of 2 months. The number of leptospirosis cases will continue to rise in the country as a consequence of rapid urbanization, cutting of trees, standard sanitation, and increased occurrence of tropical storms brought by the climate changes. In recent times, however, it was found that a heavy concentration of these cases in the country were in the National Capital Region, or Metro Manila. In fact, nearly 50% of all the cases during 2018 were in Metro Manila. Furthermore, data collected by the DOH in their quarterly surveillance reports from years 2016 to 2018 have shown that the continued increase in the total number of cases in the country per year, based on the numbers alone, there was a staggering 313% increase in the total number of cases in the country within those years. As of week 15 of 2019, however, nearly all of recorded regions have seen a sizable decrease in the number of cases as compared to the same period in that of the previous year, but Metro Manila remained constant in its uptrend. Given that Metro Manila is the smallest and most densely populated among all the regions, it brings the severity of the situation into perspective. Therefore, in order to formulate an appropriate preventative solutions for the increasing cases of leptospirosis in Metro Manila, analysis of leptospirosis with respect to the controllable area conditions was done through the journal articles whose subject revolved around the effect of water-related weather events on the rate of leptospirosis, the risk factors associated with these weather events, and the minor risk factors. Leptospirosis has always been a pressing issue in Metro Manila due to the conditions of the area being prone to house the disease. According to an article by Cesar Garcia for Rappler, from January to June 9, 2018, the Department of Health has recorded 1,030 cases with 99 dead, 6 dead, and 52 admitted in a week due to leptospirosis. The staggering amount of cases during this time of the year is due to the tropical season change from summer to rainy season. The disease is a much larger problem when storms and floods are present. This is because leptospirosis is a predominantly waterborne disease. In 2017, 2,495 leptospirosis cases were recorded nationwide. That's 49.1% higher than 2016's 1,673. Out of these cases, 261 of them resulted in death. Fast facts. What is leptospirosis? The findings of this article seem to show that the cases of leptospirosis are getting worse as the years go by. A probable cause of the disease is increase in global warming. As the summer season is getting hotter every year, the rainy season intensifies accordingly. With stronger rains amidst every year, as well as a lack of new mitigation efforts from the government, it is no surprise that the risk of leptospirosis is on the rise. Due to increasing problems that the leptospirosis brings to Manila, the Japan International Cooperation Agency, or JICA, offered to assist the leptospirosis prevention and control, along with the latest research developments at the College of Public Health of the University of the Philippines in Manila. The LabCon laboratory made an establishment at UPM CPH in partnership with JICA to provide laboratory diagnostic services to possible cases of leptospirosis in Metro Manila, as well as other areas in the Philippines. It is said that the laboratory receives up to 50 possible cases a day during the Philippine rainy season. These cases were handled by the undergraduate students and laboratory technicians provided by LabCon.
To start things off, I will be discussing the relationship between leptospirosis and water-related weather events, specifically the flooding aspect resulting from these events. So you might be asking why I chose to focus on water-related weather events. The answer to that question is quite simple. Leptospirosis, as we all know, is a bacterial disease which is commonly found in the urine of infected animals, which easily mixes with water, thus giving the bacteria a larger medium to work with. This allows for the disease to spread out much quicker and expand its reach among the population. Therefore, given the ease at which the disease may be contracted by contact with water, the changes in the volume of water must then be taken into account, given the possibility of its infection, which brings us to water-related weather events. Water-related weather events are those associated with rainfall, such as thunderstorms, habagat or monsoons, and typhoons. In my literature search, I found a study whose topic was in direct relation to my own topic of discussion. The study, entitled Extreme Water-Related Weather Events and Waterborne Diseases by Can and Company, used medical and meteorological databases such as Medline, PubMed, GeoRef, EMBase to sort through all the reported outbreaks with their respective weather conditions from 1910 all the way to year 2010. Their findings showed that leptospirosis was the second most prevalent waterborne disease in all of these cases. Furthermore, they also found that the occurrence of flood in these outbreaks as a result of weather was around 55.2%, which is an extremely indicative number. In addition, a more specific study conducted by Amelasan and Company examined the aftermath of Typhoon Ketsana, better known to us as Bagyong Ondoy, in relation to leptospirosis. After an extensive hospital-based investigation in Metro Manila, they found that a total of 471 people were admitted due to contracting the disease. Furthermore, it was found that majority of those infected were found to have waded in floodwater, which means that they somehow had contact with the floodwater during the period of the typhoon, which was likely the cause of their contraction.
As for my part, I will talk about the relationship between leptospirosis and soil. Although you may be curious if there is even any relationship at all, well, to be honest, I too was curious at this relationship. Which is why I wanted to focus on this aspect because generally when we hear or talk about the topic of leptospirosis, it is always related to water, flood, or sometimes even typhoon. People say to avoid this water, flash floods, and other water related events, but might have forgotten another aspect in which leptospirosis could be found, and that is in the soil. It must not be taken for granted that leptospirosis is prevalent as well in our soil environment. For this analysis of the topic, it is important to highlight the reason as to why and how the soil is one of the transmissible sources of leptospirosis. This reason is mainly because of the persistence of the pathogen Leptospira and its survivability in the soil. There was an environmental microbiology study that was conducted by Casanovas Masana et al. And one of their objective was to quantify the survivability of the pathogen in the soil. In this study, did you know that it was discovered that this pathogen could last or live in soils from at least a few hours up to 193 days? Factors that affected the persistence of survivability of this pathogen was the characteristics of the soil such as its pH, organic content, and the texture. It was also found that this pathogen tend to love soils with wet moisture content. This discovery was quite intriguing because the general landscape of Metro Manila soil has a wet moisture content which makes the soil around Metro Manila generally potential to contamination.
In addition, the aforementioned difficulty of identifying leptospirosis is further enhanced given the evolutions that it is slowly undergoing over the course of time. Leptospira bacterium has developed ways to fight against the immune defense and resist commercially available medicine. The high-speed movement of leptospires within cells of mammals also lets the bacteria to reach the bloodstream and spread to numerous organs in a short period of time. For this reason, immunologists are having complications in developing a potent vaccine against leptospirosis. According to a study conducted in 2007, bacterial motility, lipopolysaccharides, lipoproteins, and potential virulence factors are the concerns of current molecular and cellular studies on leptospirosis vaccines. Up until now, there is insufficient data regarding this. Based on most articles found online, the risk of infection for people who have been exposed to environments contaminated by rodents and other animals is always existent. The chance of getting infected can only be reduced by avoiding swimming or walking in potentially contaminated water. Protective clothing and footwear should also be worn when necessary. Keeping rodent problems under control and ensuring the vaccination of pets are also ways to prevent leptospirosis. However, complete avoidance of activities involving contaminated fluids is not possible. With that being said, it is necessary to find ways to answer this problem, and thus, Pharmaceutical companies and immunologists are looking for new and effective antibacterial agents because of the outbreak of infectious illnesses from pathogenic bacteria that have developed resistance to antibiotics on the market. Nanoscale materials have become known as advanced antibacterial agents due to their high surface area to volume ratio, as well as their distinct physical and chemical properties. As proven in the research conducted by Sondi and Salopek Sondi, silver nanoparticles have potent antibacterial activity against E. coli. This study incorporates nanotechnology and bacteriology that contributes to feasible developments in formulating new ways to fight bacteria.
From the examined studies, the relationship between water-related weather events and leptospirosis is made clear. Leptospirosis cases tend to increase during periods of rainfall and are likely the result of flooding, as shown in the studies. Further evidence of this is found as I looked through the Department of Health surveillance reports with regards to leptospirosis cases in the Philippines. Over the past 3 years, which found that outbreaks tend to spike during periods of rainfall commonly ranging from the months of June to October.
With that being said, it is urgent for specific solutions on how to eradicate or completely prevent this pathogen on accumulating in the soil. With the help of various tests and studies conducted by numerous researchers, we could assess and learn the burden that is brought by this pathogen, and this could serve as guides for public health interventions. After to have researching thoroughly various systems and treatments of totally preventing the disease from living in our soils, specifically in the Philippines and in Metro Manila, is still quite questionable.
To summarize the critical points of the leptospirosis problem in Metro Manila, it is safe to say that the most alarming of the bunch is the inevitability of the disease due to the climate and the situation in Metro Manila. These factors make leptospirosis in Metro Manila nearly inevitable, which poses an almost everlasting problem. Although it may not be able to be completely mitigated, there are actions that can be done to lessen the hazards. We know from the analysis of the disease that it originates from little farm animals, most especially rats, and it can be kept in dirty water or soil, which are both abundant in the city. The main priority would be to begin effectively cleaning up Metro Manila, ridding it from as much trash and any places that are prone to housing the disease. This is the most important and possibly the most effective way to mitigate the spreading of the disease, since it is impossible to completely change the city's climate and environment. This being done would be a tremendous contribution to the problem. It would reduce a number of the areas prone to housing the disease, which would ultimately reduce the chances of catching the disease. The next solution would be to increase the number of clinics with personnel qualified enough to treat people who have the disease. There would need to be more clinics per area in Metro Manila. With more clinics, it is a given that more doctors and nurses would be needed as well. A good goal would be at least one clinic in every one of the 16 cities that make up Metro Manila. This is a solution that really shouldn't be too hard for Filipinos to accomplish, since most Filipinos aspire to be doctors and nurses when they start their career. Having accomplished these two solutions, there would be less cases of leptospirosis every year, and for the cases that do occur, they will be efficiently handled in any area of Metro Manila.
Leptospirosis is an infection that originates from the pathogenic species of Leptospira, termed as spirochetes, a flexible spirally twisted bacterium. It is associated with the urine of infected animals such as rats, stray cats, and dogs. Leptospirosis can be transmitted to humans when an open wound comes in contact with water or soil that is contaminated by urine. Leptospira infection is a severe problem, especially in humid areas or warm climates with a high annual rainfall that can lead to flooding. People exposed to potentially contaminated environments are always at risk of infection, considering that complete avoidance of activities in these areas is not possible. Up until now, there is insufficient data regarding leptospirosis vaccines because the bacterium has developed resistance to antibiotics available. Hence, the development of new methods to counter this problem. Nanotechnology continues to emerge in the field of science and technology. The term nano denotes 1 billionth of a meter or 10 raised to negative 9. Metallic nanoparticles exhibit excellent antibacterial properties due to their large surface area to volume ratio, which is timely considering the growth of microbial resistance against antibiotics. The most recent studies show that metal oxide nanoparticles have a satisfactory antibacterial activity that could be efficacious to combat bacteria, viruses, and other eukaryotic microorganisms. The catalytic oxidation of metallic silver and its reaction with disintegrated silver ions plays a part in its bactericidal effect. Furthermore, 0.5% silver nitrate possesses antibacterial property against Staphylococcus aureus and Escherichia coli. However, silver nanoparticles utilized as drug decontaminants are said to be hazardous, the way that silver can cause the skin to turn purple or purple gray. In contrast to this, silver has been utilized most extensively for centuries, proving its non-toxicity in regular use in little quantity. For centuries, silver ion was used to make water safe to drink. It is also utilized in dental materials, coating of stainless steel materials, and cosmetics. This gives the notion that silver nanoparticles have low toxicity to human cells. Bacteria are not likely to withstand the properties of silver in comparison to its behavior in the case of conventional antibiotics. As stated by a study conducted in 2007, this is because the metal fights an extensive range of targets in the pathogen, that these microorganisms have to grow a host of mutations at the same time to defend themselves.
In order to address the flooding situation in Metro Manila, I initially thought of suggesting ways to improve upon the drainage system. However, after reading and pondering, I've found that it is not necessarily the design of the drainage system that is at fault, but rather the sheer amount of litter that is scattered all throughout the region, thus blocking the drainage and leading to flood. Therefore, I suggest that the Anti-Littering Law or MMDA Regulation number 96009 be amended in order to make the penalties more severe. On top of this, the law itself must be properly enforced and prioritized, since it is evident that litter is still predominant in Metro Manila. I believe that if we are able to properly do this, the amount of flood in Metro Manila will diminish greatly, and less flood will lead to less cases of leptospirosis, which is good for all of us.
But there are various methods on how to save our soils, at the very least from diseases like leptospirosis. One of which that is currently being practiced in the modern days is soil sterilization. With this method, although it does have negative side effects, at the very least, this pathogen and the contamination of soils may be neutralized. To conclude, we must always be wary and curious whenever it comes to the relationship between leptospirosis and our soil. At the same time, we must never forget that our environment suffers first from leptospirosis. In other words, our environment that we must protect has more chances of obtaining leptospirosis than us, the biotic factor of life.
To summarize the critical points of the leptospirosis problem in Metro Manila, it is safe to say that the most alarming of the bunch is the inevitability of the disease due to the climate and the situation in Metro Manila. These factors make leptospirosis in Metro Manila nearly inevitable, which poses an almost everlasting problem. Although it may not be able to be completely mitigated, there are actions that can be done to lessen the hazards. We know from the analysis of the disease that it originates from little farm animals, most especially rats, and it can be kept in dirty water or soil, which are both abundant in the city. The main priority would be to begin effectively cleaning up Metro Manila, ridding it from as much trash and any places that are prone to housing the disease. This is the most important and possibly the most effective way to mitigate the spreading of the disease, since it is impossible to completely change the city's climate and environment. This being done would be a tremendous contribution to the problem. It would reduce a number of the areas prone to housing the disease, which would ultimately reduce the chances of catching the disease. The next solution would be to increase the number of clinics with personnel qualified enough to treat people who have the disease. There would need to be more clinics per area in Metro Manila. With more clinics, it is a given that more doctors and nurses would be needed as well. A good goal would be at least one clinic in every one of the 16 cities that make up Metro Manila. This is a solution that really shouldn't be too hard for Filipinos to accomplish, since most Filipinos aspire to be doctors and nurses when they start their career. Having accomplished these two solutions, there would be less cases of leptospirosis every year, and for the cases that do occur, they will be efficiently handled in any area of Metro Manila.
However, maintaining a clean and healthy environment is not enough in inhibiting leptospira antibodies, especially in vulnerable communities. In fact, the practices to prevent acquiring leptospirosis is no longer effective. Hence, the preliminary version of a new and modern way to inhibit its bacteria. Similar to the design of wastewater treatment facilities, floodwater can be collected that will pass through a filter. Silver nanoparticles are incorporated in these water filters to achieve the removal of pathogens attributable to their antimicrobial properties. Once the quality of the water improves, it can be used for different purposes, not including drinking. This system can be executed with the help of local government units and experts in the field of microbiology. Leptospirosis infection can also be obtained from soils. Recently, silver nanoparticles have been put to use in the agricultural sector that fights off pests. From this, it can be said that these nanoparticles are non-toxic and safe. From a website called NANOCS based in New York, silver nanoparticles are priced at $285 per 20 ml, which is roughly 5,700 pesos. The plan may not be cost efficient considering that it requires a vast amount of money in order for this to be executed. However, noting how this could eventually decrease the mortality rate, investing in this treatment plan overshadows its downside of spending more than expected.